Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about the list interface in the Java collections framework. By the end of this video, you will understand what a list is, its important features, and the commonly used implementation classes, and also when you should choose a list over other collection types. So let's get started. So what is the list interface? So the list interface is the sub interface of collection. We can say it is a sub interface or child interface of collection. Collection is also one of the interface. So list is a sub interface of collection interface. It stores a collection of objects. Okay. So it will store multiple objects and provide a ordered collection. What do we mean by ordered collection? Maintains insertion order. So ordered collection means it will maintain the insertion order. That means the order in which the elements are inserted into the list, the same order the objects will be there. Okay. So it follows the insertion order. Okay. And unlike a set, a list maintains the insertion order and also allows duplicate elements. So we can store duplicate elements in the list. Okay. And also it supports index-based access, index-based operations. So let's say inside list, we have some values. Okay, whatever values 10, 20, 30, 40, and index is 0. Index will start from 0, 1, 2, 3. Suppose I want to fetch a particular index, then I can use list dot get an index, let's say 1. So output will be 20. Okay. So it supports index-based operations. It allows duplicate elements. It remember the order of insertion, and it stores a collection of objects. Instead of value, we can have here objects. Okay, it will refer to some object. It will refer to some object. So collection of objects. Okay. Let's see some of the feature of the list. Okay, so it maintains insertion order. So let's say if I insert in order 10, then 20, then 30. So in the list also it will maintain the same order. First element will get inserted will be 10, then 20, then 30. Okay. So it remembers the order of insertion in the list. Okay. And second point is it allows duplicate elements. Even let's say 10, 20, 30, comma 20. If I'm again inserting the same value which is already there in the list, even then it will allow this duplicate value inside the list. So it allows duplicate elements. It supports indexing based operation. That means let's say we have these values at index 0, 1, 2, and 3. These are the indexes. Okay. And suppose we want to get the value, we want to access the value at whatever index. So we can fetch the value based on indexes. So it supports index based operations, and also it can store null values. So let's say 10, 20, in between I will add null. So this is also valid scenario. Okay, so it has 1, 2, 3, 4, 5 elements, and the third element is null. So it allows null values to store in the list. And dynamic inside, that means if I store one more value, So size will grow automatically in the list. We don't need to do anything from our side. That will be done automatically. That is the feature of list. Okay, these are the feature of list. It will maintain insertion order. It will allow duplicate elements. It supports index-based operation. It can store null values and dynamic in size. So it allows duplicate values, supports index-based operation, can store null values, and grows or shrinks dynamically as elements are added or removed. So if we are removing elements, size will get decreased. Okay. So insertion order. Insertion order means if elements are added in a particular sequence, they are retrieved in the same sequence. Okay. So let's say, for example, we are adding apple first, then banana, then orange. And if we are retrieving means fetching the elements from list. Okay, trying to get the elements from the list, then we will get in the same order apple, then banana, then orange. So order will remain the same. That's what it follows the insertion order. So this behavior is useful in many applications actually. Okay, where the order of data matters. Okay, and duplicate elements. Okay, a list allow duplicate elements. If same value, if same value is added multiple times, see apple we have added 3 times. So if same value is added multiple times, every occurrence is stored in the list. This makes a list suitable for scenarios where repeated values are expected, such as shopping cart items, or it can be exam marks. Okay, so these are the examples. So after storing, if you try to fetch, it will come like this in the same sequence plus duplicates are also allowed. Okay, and index based access. Okay, suppose we have 3 elements in the list. At index 0 we have apple, at index 1 we have banana, and index 2 we have orange, and we are trying to get the element based on index. Let's say, for example, list.get1. That means at index 1 we have banana, so the output will be what? Banana. Okay, so we performed this operation using index. So list supports index based operation. Output will be banana. Okay, so every element in a list has an index. First element is stored at index 0, second at index 1, and so on. Okay, and focus here the method name. Okay, we are using methods like get, and inside brackets we are adding index, so you can directly access any element. Okay, and there are common implementation classes. Okay, so the list interface cannot be instantiated directly. Why? Because list is an interface. So instead, Java provides several implementation classes, and out of which the most commonly used are ArrayList, LinkedList, and Vector. Okay, we will study each of these in separate videos. Okay, and common list methods are add, get. Okay, add for adding elements, get for fetching elements, set for what? Setting the elements at particular index. Removing contains to check whether the list contains that particular value or not, to check the size, to check whether list is empty or not. Clear to remove elements. Okay, so these are the common methods. Okay, we will cover these methods as part of the examples. Okay, so some real world examples. So lists are used in many real world examples. Okay, Examples include a music playlist, okay, music playlist, shopping cart items, okay, a list of books, a movie watch list, student marks. So in all these cases, the order of elements is important and duplicate may also be allowed. That's why this this belongs to real world example for the list category. Okay, now next question comes, when we should use the list. Okay, on what criteria we should use the list. So use a list when order of elements is important, in which order they are preserved. If order of elements are important, we should go for the list. And choose it when duplicate values are allowed, when you need index based access, or when the collection size changes frequently. So what are those pointers? Order matters, duplicates are allowed, and frequent index based access is required. Okay, means in suppose in any application, uh, fetching of elements is happening very frequently. So in those kind of situation, we should go for list, and dynamic collection is needed. That means every now and then the size of list is getting changed. So in that scenario also, we should go for a list. Okay. So we have learned from this diagram. So list we have covered as part of this video. So list is what? Sub interface of collection. It represents ordered collection, that is order is significant. It will remember the order of insertion. It supports index based operation. That means based on index we can fetch the element. It allows duplicates. Okay, I have written here some of the short forms. So duplicates in the sense we can store multiple values. Okay, means duplicate values in the list, that is allowed. And also we can store null values. And since we cannot create an object of this list, since it is an interface, we have the implementation classes, that is ArrayList, LinkedList, and vector. Okay, so we can use this implementation class to create an object. Okay, so as part of this video, we have covered list. Okay, so let's quickly summarize what we have learned so far. So list is a sub interface of a collection. It maintains insertion order. It allows duplicates. It supports indexing. We have seen the same in the diagram. Okay, and common implementations are ArrayList, LinkedList, and vector. So that's all for this video. I hope this tutorial helped you understand the list interface in Java. Thanks for watching, and I will see you in the next video.